welcome back coders. In this video, we will be discussing the question linked list to stack adapter. What is an adapter? Adapter is a way in which we can make a class work as a completely different class. So in this question, we will be making our linked list work as a stack. So as you can see that all of the functions that we have to write, size, push, pop and top, all of these functions are of stack, but we have been given a linked list and we'll use our linked list and make it work as a stack, and we'll do it on the complexity of O1. All of these functions should work at the complexity of O1. So try to do it on our own, and if you can't, just see the solution part. I'll be discussing the solution next. I hope you tried it on your own. Let's discuss the solution of this question. So first of all, what is a stack? Okay, so in stack, we add and remove from the same end. So if we write push 10, 10 will be added to the stack. If we write push 20, 20 will be added at the top of 10. If we write push 30, 30 will be added here. Now if we write top, our 30 is at the top of the stack, so it will return 30. If we write pop, it will remove 30 because 30 is at the top. So we are adding at the same end and removing it from the same end. But if we see in a linked list, we can add first, we can also add last. We can remove from first and we can remove from last. But we have to make it work as a stack. So we'll be adding at the same end and we'll be removing from the same end. So it works as a stack. Also, we can get from first and we can get from last as well. We can get any index, but we won't be needing that. We'll just need the first and the last. So there are two pair of functions that can be used. There is add first, get first and remove first. Another pair is add last, get last and remove last. So all of these functions can be used together to make it work as a stack. This can be used or either this can be used. Now let's discuss how we can use these functions to make it work as a stack. First of all, we'll discuss about add first, get first and remove first. So this is a stack. We'll be adding at first in our linked list. So we added 10. Now we'll add 20 at the first position. So 20 is pointing towards 10. We added 30 at the first. Now if we use get first function, it will return the first node and first node is 30 and also 30 is at the top of the stack. So it works as same as top function. And our add first function is working as push. If we say remove first, so our first node will get removed. So it works as pop. Now another pair. Add last, remove last and get last. So all these functions can be explained as, if we write add last 10, now we'll add at last 20, 30. If we write add last, it will work as push. Our get last will work as, it will give us 30, so it will work as top. And our remove last will remove the last node, so it will work as pop. So all these functions will make together work and make it look like they're working as a stack. So we can use either of these pairs, but we'll be using add first, get first and remove first function because we have to do it in the complexity of O1. And all of these functions are work in the complexity of O1. Let's try to code this. So we have to write 4 functions: size, push, pop and top. For the size function, we'll just return the size of list. We'll return list.size and will give us the size of stack. If we write the push function, we'll just have to add at first because we are using add first, get first, and remove first. So we'll just list.add first and we'll just add the value. For the pop function, first we'll have to check whether the size of the stack is 0 or not. We'll check whether size is equals to 0. If our size is 0, then our stack does not have any elements. So we'll just print system.out.println that our stack is underflow. And we'll just return -1. If that is not the case, if our size is not 0, then what we'll do is we'll just get our first element, list.getFirst, and we'll just remove it, list.removeFirst, and we'll just return the value. For the top function, we'll do the same thing as pop. The only thing that we won't do is we won't remove it. We'll just provide the value, we won't remove it. So we can just remove this line and our function should work fine. Let's see whether our code runs. It is giving us compilation. Okay, so our system has an E, but it should not have an E. Okay, now we run this program. And it is accepted. So we submit this and we check whether it's working for all the test cases. And it is the correct answer. So thank you for watching this video. I hope you liked it. Make sure to subscribe to our Pepcoding channel and I'll see you in the next question. Thank you.